Okay, welcome back. In the last episode we installed the crankshaft. Now it's time to put the pistons in. 4 pistons. So these are 30 thou oversized pistons. They come as a set with all of the rings and everything pre-installed, and everything should be ready to drop straight into the motor. These particular pistons are from Turner's Engineering. I have no idea who their supplier is. The pistons are unbranded. And by the way, you buy whatever size pistons your machinist tells you to get. So they will measure your worn block, tell you what size to buy. You buy the pistons, take them to the machinist, and then they machine the block for perfect clearance to those exact pistons. Now, when pistons come with rings already on them, everything should be fine to drop into the motor. But we're going to check the ring gaps just to make sure. Put it into one of the cylinders. And now, because I am on video, and 1,000 of you will tell me I'm doing it wrong if I don't do this, I am going to push it down with a tool to make it nice and level. This is a piston ring leveler 2000. No, it's a piece of plastic. And if we look in the book, you will see that we are looking for a gap of 15 to 20 thousandths. That does not apply to the diesels, okay? The diesels are different. You need to check the book. Where is 15? We have 15. Let's see what it is. Do we have 16? We do have 16. Let's see if we have 18. We do not have 18, so we're at about 16, which is fine. That's good. I did manage to find one that was a little tight. I'm sure it would have been fine, but we'll get it within spec anyway. And it is a little tight. It's not quite 15. Okay, so I've just got a bar of steel with some sandpaper wrapped around it in the vise. We just take the ring that's a little tight and push it across the sandpaper. And I believe the correct technique is to push against the outside edge. Presumably that stops you from developing a burr on the edge, but I think some piston rings have a chrome edge, and if you go this way, you can tear the chrome away. Nice and square. And I reckon that'll do it. 15. But one more little tickle. Okay, 15. So that it was just 2 gentle short strokes, and that took 1,000th off. Oh, and I'll just point this out because you may have noticed. Yes, there is a little grubby spot at the top of a couple of the cylinders that didn't quite clean up with the rebore. That's because somebody's been in here scraping in the past, and they got a little too aggressive on a couple of the cylinders. It's not an issue at all. The piston rings don't get anywhere near this edge, but just pointing that out in case you thought that was a little weird. Okay, so that's the pistons all checked. They are fine. We'll twist these around and things when it's time to put them in. Now let's, for fun, see how good these completely unbranded pistons are. We're not balancing the engine or anything, but it would be nice to know that the pistons are kind of close to each other. 682. And we'll zero that. 1. Okay. Just write +1. 2. Okay. 2. I would think from the factory they were better than this. Let's weigh the Conrods. This is number 1. Zero that. This is number 2. 0. See, Land Rover were pretty good. Number 4. 0. Number 3. 0. Okay. Thought I was joking when I said that Land Rover probably did better than 2 grams, didn't you? I would like these to be within 1. Just to be clear, you don't have to do this. Put your pistons in and move on with your day. I think within 1 gram is considered pretty good. So 2 grams on a motor like this, I mean, are you really going to notice?
In saying that, I bet the original pistons were bang on, because it's easy for Land Rover. They've got hundreds of pistons that they can sort by weight and make sure that 4 matching ones go into each engine, as you just saw with the Conrods.
Okay, so normal sort of way to do this, again, I'm not an expert in this at all, is to remove material from the underside of the wrist pin boss. However, these being aluminium pistons, I think 2 grams is quite a bit, and I'm not sure we want to do that. So instead, let's try and remove a little bit of material from a couple of the wrist pins.
Because what we're concerned with is the total weight of the piston assembly. So rather than remove a lot of aluminium, which might weaken the piston, I'm going to remove a little bit of heavy steel from the wrist pin.
I'm just going to carefully go a few times. I'm not looking for perfection, but we may as well try and get them closer. And I'm going to go and do that outside so I don't make a mess in here. I'll be back in a second.
And yes, I did weigh the wrist pins first, and they are all exactly the same. If there was a variation in the wrist pins, we could have mixed and matched to balance things out. But there isn't, they're the same.
You can see I just took a smidge off the inside there. Basically rounded off the chamfer that was already there.
Okay, let's see how we did. First of all, zero out the scale with an untouched one.
0.
And now let's compare that to the one that I just removed material from.
-1. Perfect. 0. -1. Good. So we've got our 2 -1s and our 2 zeros. So now, if maths is even real, if we put number 1 on there with a 0, that's 0. This should in theory be +1. It is +1. This should in theory be +1. +1 and +1. So if this is 0, these 3 are within 1.4 grams of this one, and these 3 are within a gram of each other. Of course I had to make them all 0. Sort of. I'm at the point where I've maxed out the Gold Air technology. So we got 0, 1, 1. It was 0 a second ago, I promise. 0, 0, 0. There we are. So I think we're within 1 gram, and we're within the accuracy of this little machine anyway. Oh, and just in case anyone thinks I'm destroying the engine, here's one of the original wrist pins, and here's one of the new ones. And you can see that there is plenty of extra meat on the new ones. So it's not like removing a tiny slither from the inside is going to cause them to break in half or something. Right, Conrods. Now, we've got to do the same bearing check on these that we did on the crankshaft. I'm only going to do 1. Okay, new bearings. And these also have a little notch, just like the main ones. And these are the old nuts, but we will use brand new nuts when we put this in the motor. Undo one side. Now this gap should be between 4 and 8. That's 4. And 8 goes in 2, so we're a little over. Okay. 9 is tight. In fact, I can't get 9 in on the inside.
So this is fine. It's 8 thou right behind the bearing, which is within spec, and at the tight end of tolerance. Plus, these are good quality King bearings, so I'm more inclined to trust that that tight fit is by design.
See that hole there? That is an oil feed hole for this. And this small hole is what squirts oil up into the cylinder. So we need to double check that that's clear. Second thing to note, see these bolts or studs or whatever they're called? The head of those is an oval, a roughly shaped oval. And that's what stops it spinning in the hole. So if you happen to have these out, you want to make sure that this seats properly before you go tightening the nut up. Because if it's seated awkwardly, say twisted or whatever, well, first of all, it might not pull into the hole nicely, and secondly, it could smash this to pieces if you really start wrenching on this end.
Also, on these connecting rods, there are very often thin edges where Land Rover machined the recess for the bolt heads. If they look like this one, I break the little sharp bit off with pliers and run a small file over the edge. You don't need little shards of metal breaking off inside the engine.
And I believe protocol is to put piston clips in so that the open end is pointing downwards. Now, I don't think there's a right or wrong way to put these particular pistons in, but we'll do them all the same, and I'll put this block of text towards the front of the motor. So if this is the front, we need to make sure our Conrod is pointing towards the front. And the bottom of all the caps have an arrow stamped into them. This one isn't a very good example. There you go. Towards the front. And these are marked, a 1 here and a 1 here. Those go on the same side. Also, if you recall, I added very light center punches to each one. So there's 1 dot there and 1 dot there. So those 2 dots go together. There's some lube and everything. I already put a smear in here. And now, there we go. And the other circlip. Make sure that's in properly, because it would be a disaster if it wasn't. Same on the other side. Very nice. Let's do the next part. The rings say top on them. So just quickly make sure that we have got them all facing upwards, which we do. Now the other thing, this oil control ring down the bottom here has a spring inside it, as you can see. And first of all, you just need to make sure that that's properly seated inside it. And secondly, this spring has a join somewhere around it, and presumably you don't want that join to be where the ring gap is. So I've positioned that so that it's right in here on the opposite side. And you've all probably seen this, but we need to spread out our piston ring gaps, like the Mercedes Star, something like that, so that the gaps are staggered, so our gas doesn't blow straight through. I believe they move around once the engine's running anyway, but you're supposed to start them off like that. A little bit of lube, especially on the oil one where it needs to close. And now one of these awful things. Okay, now we're ready to go into the motor. No, we're not quite ready. I'm going to wrap a bit of tape around the threads so we don't scratch the crankshaft on the way through, because what kind of an idiot would do that? Okay, so this is number 1 here. Make sure that's nice and clean. And I'm not going to put assembly lube on here to start with, because we've got to do our clearance check. We'll just wipe a little CRC on the bearings though, so they're not completely dry. And now I think it's easier to do it the other way around, with the top on the top. Make sure the cylinder is nice and clean, which it should be. And I think that Lucas stuff is a little sticky. We might just get the piston stuck in there. So I'm going to put some slideways oil down in here. That's just oil I use on my lathe for the slideways. And we're on a bit of a lean, so I've put some tape on the downhill side of the Conrod as well. just so we don't scratch stuff. Easy. Easy. I've got the crankshaft so that it's furthest away from us, so we shouldn't be anywhere near it yet. Just tap it in whilst giving the motor a bit to guide it around the crankshaft. Flip it over, hope it doesn't fall out. And Plastigauge, that's too long. I'm not going to do all of them, but we'll do one of them just to check. And this is number 1, pointing forward. .25 foot-pound, of course, which isn't a lot. We'll check the end float while we're there. 7 to 12. Well, we will have 7 because this is all original. We do not have 12. There's 7. Okay, in between 7 and 12. Good, perfect. Now let's have a look at this Plastigauge that I probably just mushed all around. All right, I think you can see that okay. Where are we at? About there, 2.5 thousandths. What are we supposed to have? About 1 to 2.7. Okay, well it's definitely fatter than 2.5 and thinner than 2. So that is good.
So now the caps can go on for good. And yes, I did push the connecting rod back off the bearing so I could get lube underneath as well. And of course I'm using new nuts. You don't reuse nylock nuts in a case like this. But here's where we hit a bit of a snag.
These are not locking nuts like the other ones were. Let me have a closer look. They may have a split thread or something going on.
No. So here's the situation. The original nuts were nylock. You're not supposed to reuse nylock nuts anywhere critical because they lose grip each time you take them on and off. Plus, the service manual specifically says, replace these nuts, in capital letters no less. Hence, I ordered new Conrod nuts. So why aren't the replacement nuts nylocks? Well, these original nuts are actually an aviation nylock. A normal nylock is the same size as the equivalent plain nut, more or less, so the nylon takes away a couple of threads, while these special aviation ones have the full thread plus the nylon as an extra. And I guess the aftermarket Land Rover world was like, yeah, nah, we source parts from China, not Boeing. So instead of nice aerospace lock nuts like Land Rover used, now we get plain nuts like you can buy from any hardware store for 5 cents. And you use Loctite, I suppose. Anyway, for now, I'm just holding everything in place with the old original nuts. We'll put the other pistons in and then decide what we're going to do about this nut situation.
Make sure the arrow is pointing towards the front. Just a little snagged on one of the dowels. There we go.
So here's what we're going to do about the nuts. I'm just going to reuse the old ones. Look, if we're just going to be replacing them with plain nuts and Loctite, I may as well just reuse the original nuts with Loctite. Because if we don't need the nylock, why would I throw 8 aerospace grade nuts in the bin that probably cost $10 each and replace them with generic plain 5-cent nuts from the back streets of Mumbai? Doesn't make sense. Plus, it'd be good to keep the original nuts with the engine. so then the next guy can see what they're supposed to look like. So that's the plan.
Just clean these out with some brake clean. And these threads, don't want to spray too much of this stuff around the place. And some Loctite. This is just normal blue Loctite. You know what they say. Don't be an egg. Don't use red.
I'll just pause here for a second. When you torque a nut or bolt with a torque wrench, you approach your final torque with a smooth sweep. Because you'll often see me do an extra click afterwards. That does nothing. It's just a habit, a bit of mental reassurance. You got to make sure that you didn't miss the nut that you just torqued up 1 millisecond ago.
25 foot-pound is not much. And generally what I would do is come back and check later. Say, before I put the sump on, I'll go click, 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 click. But because we're using Loctite, and I can't do that, I'm going to mark them. Because as I said earlier, it's easy to miss something when I'm fussing about with cameras and thinking about dumb things to say. Can we just take a moment to applaud the geniuses in the Loctite marketing department who decided to rebrand the medium strength thread lock as Super Nut Lock. So I'm standing in Repco and they have 2 Loctites, high strength and super. Guess which one is medium? Great job.
Now, you may notice that there is one missing. Yeah, that's because somehow we ended up with a chipped piston ring.
You might be able to just see, but there's a scrape mark leading from about here, tink, through there.
I'm assuming the ring came like this because it's not like I've been bashing the rings with screwdrivers or anything like that. But I don't know for sure. So I'm not going to go hassling turners about it. And a new set of rings costs $10. It's not a big deal. The problem is that I can't get a replacement from Turners because their shipping to New Zealand starts at $100. That's the minimum. And I've asked them before about shipping small items just in normal post, but they won't do it. Anyway, I need to put an order through with paddocks for a bunch of other stuff, so I'll get a set of rings with that order. For me, that's going to delay things by a few weeks, but for you, not so much.
Now, these new piston rings, I'm only replacing the damaged ring, not all 3. These are Brit part rings, and this top ring is plain cast iron, whereas the ring that came with our pistons was a chromed ring. It's still a cast iron ring, but with a chrome edge. So anyway, there's no issue with this being a plain cast iron ring in terms of performance or anything like that. It's completely fine. In fact, I think all of the original Land Rover rings would have been plain cast iron anyway. However, it is a little weird that we're going to have one piston with a different top piston ring. But aside from that, it's not an issue at all. There we are. Now, because this top piston ring comes from a different manufacturer from the piston, I am going to check the clearance up and down, which should be 1.8 thousandths of an inch to 3.8 thousandths of an inch. I don't have a feeler gauge that measures those numbers, so we'll say 2 to 4. It's not going to be too tight. 2 slides in, no problem. Where's 4? Four goes in, but it's tight, as you can see. Just check 5. Yeah, no way 5's going in. 3.5, let's just see. Yeah, that's dragging. So 3.5 thou is dragging. Okay, we're fine.
So we're fine to run this piston ring. It's in spec. It's on the loose end of okay, but it is in spec. In saying that, there's going to be a gap between building the motor and running it while I sort out all of the accessories. If in the meantime I can get a ring from Turner's, I'll swap it. Because the rings that came with the pistons were a tighter fit. Plus it would just be nicer if they were all matchy-matchy. To be clear, what we've done here, I'd 100% run it in my own Land Rover. No problem. It'll be fine. Like, good as new fine. But if someone else is going to pay good money for this motor once we're done building it, I want to make sure it's as good as possible. So I probably will end up swapping that ring out. For now, the pistons are done. Next, we'll be installing the camshaft and timing chain.